This is part one of the stoichiometry notes. In this video, we're going to talk about what stoichiometry is and mole-to-mole conversions. You'll find the other three parts of these notes in separate videos. All right, so part one, what is stoichiometry? Stoichiometry tells us the relationship between quantities in chemical reactions. And so another way to think of it is that stoichiometry is the math of chemical reactions. Like that. And so in order to do this math, we need a balanced chemical equation. It's going to tell us the ratios of all of our different chemicals we're dealing with in the coefficient. And so those coefficients are telling us the relative number of molecules, or since we like to kind of use that bigger unit of moles, it's also a ratio of moles when we are kind of looking on that larger scale. And so if we look at this hydrogen plus oxygen producing water, H2 plus O2 produces H2O. In order to get this balance, we need those coefficients of 2 in front of hydrogen and H2O, meaning that we need 2 hydrogen molecules in order to fully react with 1 oxygen molecule and to produce the 2 H2O molecules that we need. And so stoichiometry, we use the ratio that's found in that balanced reaction in order to define the quantity relationships that we need. And so using the balanced reaction to find the ratio of moles for each chemical, that mole ratio allows us to look at the mathematical relationships. We also, if we don't have moles of oxygen or are looking for moles, we also do have our other conversions. We know 1 mole is equal to molar mass for a given chemical. We also know 1 mole is equal to 6.022 times 10 to the 23rd molecules. And so these can also be used if we're going between moles, molecules, and grams for a specific substance. But in order to talk about what's the relationship between hydrogen and the relationship between oxygen in this reaction, that's when we use these mole ratios. And so we're going to write a ratio of the number of moles of whatever substance we are starting with based on the problem we're given to a ratio of the number of moles that our problem is asking us to find, or information about the chemical that we want to end up with. Now that we know what stoichiometry is, how can we do a mole-to-mole conversion? And when we're looking at this, we need a balanced chemical reaction. I've provided this reaction for us. So we're looking at glucose reacting with oxygen to produce CO2 and H2O. So if we fill in the mole ratios below with the correct values, and we can use this to write, you can write ratios using the colon, you can use an equality, or we can use a fraction. We're going to use a fraction when we're looking at writing this to do a calculation. And so if we look at, well, how many moles of glucose, C6H12O6, is to a ratio of moles of oxygen, once we have that balanced chemical reaction, we look at those coefficients. And so I have, remember, if we don't have a coefficient written, that represents 1. So 1 mole of C6H12O6 to, now we look at our oxygen, to 6 moles of O2, that would be the mole ratio between those two. Looking at the next one, moles of CO2. Well, in front of that CO2 in our balanced chemical reaction, we have a 6. So 6 moles of CO2 to our moles of H2O also has a 6. So that would be a 6-to-6 ratio. If we could simplify this, but when we're looking at writing these, because we're using this to do our math and do a calculation, we don't necessarily need to simplify this to be a 1-to-1 ratio. What with these values, our focus is that in the entire reaction, the ratios are as simplified as possible. All right, and then in that last one, moles of H2O to moles of glucose. Well, we had those 6 moles of H2O to that again, there's a coefficient of 1 in front of the glucose, and so that is a 6-to-1 ratio. And these ratios are what we are going to use in order to do conversions. If, let's say, now we want to look at how many moles of oxygen are required to combine with 0.25 moles of glucose. So if we know how much glucose we have, we want to look at, well, how much oxygen is required to use up all of that glucose in the reaction. And that mole-to-mole conversion is going to be a one-step molar conversion because we're going to be able to use that moles of glucose to moles of oxygen ratio as our one conversion factor. Our setups for these are the exact same as when we were doing our other conversions, but now we're using that mole ratio instead of one of our other two conversion factors. Those other two conversion factors that we had were the 1 mole is molar mass and 1 mole is molecules. So looking at this problem again, we have 0.25 moles of glucose, and that glucose is C6H12O6. That's my given. Now I'm going to write my conversion factor. Remember, with those conversion factors, what we want to get rid of or cancel goes on the bottom. What we want to end up with goes on the top. And so if I'm looking at getting rid of those moles of glucose, that molar ratio for glucose is going to go on the bottom. And we get that 1 mole of glucose. That's coming from that 1 mole of glucose that we see in our reaction. This problem is asking us for moles of oxygen. So how many moles of oxygen are required? Well, that means we want moles of oxygen in the numerator, but we do need to look at, okay, how many moles of oxygen are there in this reaction? We would need those 6 moles of oxygen with that. Now that we have that set up, we can go through and do that math. Anything in the numerator gets multiplied, so 0.25 times 6, that's 1.5 over, this has a 1 underneath with no unit, so 1 times 1, so divided by 1. So 1.5 divided by 1 is 1.5. And then we need our units, moles, and we do have to say what chemical this is now that we are looking at switching between our different substances with that. And so we need a number, then we need our unit. Unit could be moles, grams, molecules, and then we need the chemical. All those 3 parts in our answer with that. So number, unit, chemical, those 3 parts. And again, looking at our sig figs, 0.25 is 2 sig figs. Our molar ratios do not have sig figs because those are our exact numbers. And so that starting value is the only thing in this setup that is going to determine sig figs. So that's 2 sig figs. So we leave our answer with those 2 sig figs. All right. How many moles of carbon dioxide would be produced from 0.25 moles of C6H12O6? With this one, we have that same starting value, 0.25 moles of C6H12O6. Showing our work now, we're using that setup. We want to get rid of moles of glucose, which means our moles of glucose go in the bottom of that conversion factor. We use the 1 from within that reaction. This is looking for how many moles of CO2. So asking for those moles of carbon dioxide, which means that we are going to have 6 moles of CO2 because that coefficient of 6 in the reaction. And then we can go ahead and do that math the same way we would before. 0.25 times 6 divided by 1, and we also get 1.5 moles of CO2 is our answer. All right. Notice that because we're looking at that glucose, which is 1 mole, and then our oxygen, CO2, and H2O, all of those have those coefficients of 6. That means that for all of those reacting with this much glucose, that because that molar ratio is the same, those answers are going to be the same. All right, looking at number 4, how much glucose would be required to produce 1.2 moles of H2O? We're now starting at 1.2 moles of H2O. That was the given value in our problem. We are looking for how much glucose, and I didn't specify, but I want how many moles. I would specify better in the future. So we want to get rid of moles of H2O. We want to end up with moles of glucose, C6H12O6. Where do we get those values? We go to our reaction. So I'm going to have 1 mole of glucose to 6 moles of H2O, and then we can go through and do our math. 1.2 times 1 is 1.2, divided by, there's a 1 underneath here, 1 times 6, which is 6, and then we get 0.2, and then our unit, moles of C6H12O6 with that. And I actually need to check my sig figs. 2 sig figs here. Our molar conversion doesn't have sig figs, so I do need to add 0.20 in order to maintain my sig figs. All right, this is the end of video 1. Continue on to video 2 to look at gram to gram conversions.